Okay. So if somehow I show that angle 1 is equal to angle 2, so obviously 1 is equal to 40 degree, right?
Yes, ma'am.
So I cannot directly take that angle 1 is 90 because I don't know whether angle 1 is equal to angle 2 or not. So the first step is to show they are equal. That we can do from congruency. If we show this triangle is congruent to this triangle, from CPCT angle 1 is equal to angle 2. Clear? Let us start congruency first of all. Okay, so uh, in triangle OAP and triangle OPP. Okay, so first thing PO is equal to PO common. I can see that, right? Then also OA is equal to OB, both are radius, right? And then angle OAP is equal to angle OBP is equal to 90 degree, and here you have to write the theorem. Is that okay?
Yes, ma'am.
Please write the theorem that the tangent at any point to a circle is perpendicular to the radius through the point of contact. So which criteria is it now? RHS, right? Okay, so by RHS criteria, triangle OAP is congruent to triangle OBP, and by CPCT, angle 1 is equal to angle 2. Yeah, written now.
Yes, ma'am.
Okay. Now since both the angle are equal, so obviously one is 40 degree. From common sense you can say, or you can show also that angle APB complete is 80 degree, right? So you can break it. So angle 1 plus angle 2 is equal to 80 degree. Angle 1 plus angle 1 is equal to 80 degree because 1 and 2 are equal. So twice of angle 1 is 80 degree, and that implies that angle 1 is 40 degree. Okay. So angle 1 is 40. So in triangle OPOAP now. So in triangle OAP, right? So angle 1 plus angle PAO plus angle AOP is 180 degree. Angle sum property. Just put the values now. So angle 1 is 40 degree plus PAO is 90 degree and AOP you have to find. How much is AOP now?
$50.
Yes, it will be 50 degree. Harsha, okay?
Yes.
Okay. So AOP is 50 degree, right? Now next question number 4 quickly.
Ma'am, can you just one show the first question?
First question. First question. Yeah, this was first, I think.
Okay, ma'am. Thank you, ma'am.
Right, fourth. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. Okay, so you have a circle here and let's mark the diameter. So let's say AB is diameter, this is the center O. So the tangents drawn at the ends of a diameter. So there's a tangent here and another tangent here. Please use a scale or something to draw. I'm just drawing it roughly. Uh, to give it some name, let's say PQ and RS. Oh, what is given now? AB is diameter, right? And PQ is a tangent at point A, and RS is a tangent at point B. This is given to you. Now to prove, you have to prove that PQ is parallel to RS. Okay. See, this is simple. When you have to prove that the two lines are parallel, so we use the converse theorems, right? We can use the converse of alternate angle theorem also. Just a recall. Let's say I have two lines, right? And this is a transversal. Okay.
Yes.
This is angle 1 and this is angle 2. Let's say the lines are L and M. So the theorem is that if the lines are parallel, that means if L is parallel to M, so that implies that angle 1 is equal to angle 2, alternate interior angles, right?
Yes.
Okay.
Yes, ma'am.
And the converse theorem is that if angle 1 is equal to angle 2, so that implies that the lines are parallel, right? So the same thing we can do here also. If we take AB as a transversal, right? And so what are the alternate interior angle? One angle is this, another angle is this. So if we show that the alternate interior angles are equal, that means the lines are parallel. And that we can easily show. That is 90-degree here. Okay. Okay. So this will be the approach basically. So one by one, PQ is a tangent. You can give some name 1 and 2, angle 1 and angle 2. So PQ is a tangent, right? So therefore OA is perpendicular to PQ. Please write the theorem, okay? I'm not writing it again and again. You can write PQ. Okay, OA is perpendicular to PQ and therefore angle 1 is 90-degree, right? Okay, again also, so RS is a tangent, right? And therefore OB is perpendicular to RS again with the help of theorem. What is the theorem? That the tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, that theorem you have to write. And therefore angle 2 is also 90-degree. So I'm taking angle 2 on the right hand side because ultimately I'm interested in alternate angles. Okay. Okay. Uh, so now for lines PQ and RS, AB is a transversal, right? So if we are thinking of two lines PQ and RS and AB as a transversal, so angle 1 is equal to angle 2. Already like we have proved. So since alternate interior angles are equal, so therefore the lines are parallel, right? The lines you can say PQ and RS are parallel. Hence, you can say PQ is parallel to RS.
Ma'am, can you once show the given?
Yeah, so given was that AB is diameter, PQ is a tangent at point A, RS is a tangent at point B.
Okay, ma'am.
Yes, Rida, written?
Yes, ma'am.
Okay. See, this question can also be proved in another way. If you take this angle, right? The left one only. So ultimately angle 3 is also 90-degree, right? From the theorem. So you can also use co-interior angle theorem. That if the two lines are parallel, the co-interior angles are supplementary. Remember? So here we can also use the converse of that theorem. Now because angle 1 and plus angle 3 is coming out to be 180-degree, and therefore the lines are parallel. That also you can do. Okay. Question number 5 now. Okay. Anyway, I was just doing this question in the previous class if you have seen it, but let us do it again. So prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. I mean, it's not a very good question, but anyway. So there's a circle here and there's a tangent. This is the center O. Let's say the point of contact is P. You can call it AB, right? So write down what is given to you. So AB is a tangent at point P to a circle. So circle is denoted like this. We can call it C, whose center is O and radius is small r, like that. This is how we denote a circle. Okay, so AB is a tangent. That's it. Now you have to prove. See, ultimately you don't have to prove anything new here. Try to understand. You ultimately have to prove that OP is perpendicular on AB, right? But we will write it in some different words. Uh, just write it in a sentence, I think. Uh, to prove that perpendicular at the point of contact to the tangent passes through the center. Please write it this way. Okay. Okay, let's do the proof now. Okay, so first of all, AB is a tangent. This is given to us. Okay. AB is a tangent at point P. Okay. So therefore, OP is perpendicular on AB, right? With the help of theorem. Please write the theorem. And therefore, angle OPB is 90-degree, right? That means this angle is 90. Okay. Now let us assume any point X. Let's say somewhere here, I assume a point X, right? You join it. So assume a point X such that, so I'm assuming it this way, that XP is perpendicular on AB. See, obviously there is no point like that, but I'm just saying there is a point, but XP is perpendicular on AB. Is that okay? Now, if this is perpendicular, so I mean, that implies that angle X P is equal to 90 degree. This is the meaning of perpendicular, right? Now, if you compare equation 1 and 2, both angles are 90 degree. So ultimately both the angles are equal, right? So from 1 and 2, the RHS is both 90. So that implies that angle OPB is equal to angle XPB. Now this is only possible when X is passing through the center, isn't it? Yes. See this angle and this angle. I am saying the both are equal. So thi- this is only possible when XP is actually passing through the center, isn't it? So that means any perpendicular to the tangent has to pass through the center. Understand? This is only possible when XP passes through O. Understood? So hence we can say that perpendicular to tangent passes through the center. That's written. Okay, the length of a tangent from a point A, you draw a circle and then any point A. Let's say I have a point A here. The length of the tangent from a point A at distance 5 centimeter from the center of a circle. So O is the center. So this point A is at a distance of 5 centimeter. Of a circle is 4 centimeter. So this distance is 4 centimeter. Find the radius of the circle. This is same as question number 1, isn't it? Now quickly do it, all of you. I'm not doing it. Complete it in your copy.
3 centimeter.
Yeah. Yeah, oh yeah, that you can see, but write it properly with the help of theorem and everything. So I think we can move to next question now, number 7. Yes, Rita, can you complete that?
Yes, ma'am.
Okay. Okay, so two concentric circles are of radii 5 centimeter and 3 centimeter. Find the length of the chord of the larger circle which touches the smaller circle. Okay, so basically concentric means they have the same center. Okay. Okay, so you have a circle and then you have another circle. Sorry, it's too messed up. Okay, find the length of the chord of the larger circle which touches the smaller circle. So if I draw a chord here, so this is a chord for the larger circle, right? And it is touching the smaller circle, so it will become a tangent for the smaller circle, right? Okay. What you have to find? Find the length of the chord. So you have to find the length of this tangent. Mm, so how can we do that? Okay, let's give it some name first of all. Let's say this point, this is PQ, this is point A.
Ma'am, if we draw perpendicular from the center,
Hmm.
ma'am, by using Pythagoras.
Okay, so that means you are joining this, right? OA
Yes,
will
yes.
be the perpendicular to the tangent. Okay.
And then OP and OQ would be known because of the radius.
Yes, okay.
So we can find AP, and AP
Mm,
would be PQ would be twice of AP.
yes, very good. No, we cannot simply say twice.
And the perpendicular would divide the line
Yeah,
equally.
yes. So that theorem we have to use that the perpendicular from the center bisects the chord. Remember?
Yes.
Yeah. Yeah. Okay. So the approach is fine. Let us write it properly. Okay, Rida? Just write whatever is given to you. Here, the radius, that means OP is equal to OQ, which is equal to 5 centimeter, right? And the radius of the inner circle, that means OA, which is 3 centimeter. To find the length of PQ. Okay, proof. Hmm. Yeah, so same way we will start, right? So PQ is a tangent to smaller circle at point A. Okay, so that implies that OA is perpendicular on PQ and therefore angle OAP is equal to 90 degree, right? So this angle is 90 now. So we can use Pythagoras theorem. So using Pythagoras theorem, so OP square will be equal to OA square plus AP square. So OP is 5 centimeter whole square. OA will be 3 centimeter whole square and AP square. So this is 25 centimeter square minus 9 centimeter square is equal to AP square. So 25 minus 9 is how much? 16. Okay, so 16 centimeter square is equal to AP square. So square root of 16 centimeter square is AP and AP is 4 centimeter. Okay, so AP is 4 centimeter and yeah, so now we can say also AP is equal to AQ. Why? Perpendicular from the center bisects the chord. Okay, so AP is equal to AQ. So that means AP is equal to AQ. They both are 4 centimeter now. All right. Now you have to find the length of what? PQ, right?
Yes.
PQ. Okay. So PQ is nothing but PA plus, or you can say AP plus AQ. And that means 4 centimeter plus 4 centimeter, which is equal to 8 centimeter. You can conclude with the line in the language of the question that hence the length of chord, the length of chord of larger circle is 8 centimeter. Hamna, is everything understood now? Is she here? Yeah, okay. Hamna, any problem? You can type if you can. Okay, next question number 8. Okay, no problem, fine. Yeah, now see here. A quadrilateral ABCD is drawn to circumscribe a circle. Circumscribe means like all the sides are actually touching the circle, okay? Prove that AB plus CD, AB plus CD, okay, is equal to AD plus BC. Okay, no issues here. First of all, write down what is given to us. A quadrilateral ABCD is drawn to circumscribe a circle. To circumscribe means that this side is touching the circle. So basically, DC is a tangent to the circle. Understand? So DC is a tangent at point R. Similarly, CB is a tangent at point Q, and AB is a tangent at point P, and AD is a tangent at point S. This is already given. Okay. And to prove is written in the question that AB plus CD is equal to AD plus BC. All right. Proof now. See, this is not tough. Here we will use the theorem that the length of the tangent is equal from any external point. Okay. So we can write the theorem first. So we will not need to write it again and again. So we know that the length of the tangent drawn from same external point are equal, right? Okay, now so we can say that dr is equal to ds. Just look at it like this. Uh, See, DC complete is a tangent, right? So dr is also a tangent, the part of DC, right?
Yes.
Okay. And ultimately, in that theorem, we actually take the distance like this. Just see here, if you have a circle and you have an external point, right? If you have a tangent here, and this is the point of contact. So this point is A and B. So there's no issue. The tangent can go like up to infinity, it can go, but we only take this length from the point and till the point of contact. Understand? So DC is a tangent, but we are only interested in length dr according to this theorem. Understand? So dr is the length from the external point to the point of contact of the tangent and the circle. All right, so dr is equal to ds. And mm, similarly, we will get cr is equal to cq, right? And then we will get uh, bp is equal to bq, right? And we will get AP is equal to AS. Is that clear? You can give it names 1, 2, 3, and 4. So ultimately, I have to add all of them. So adding 1, 2, 3, 4. Now, please see one thing very carefully here. Um, See, on the left hand side, I want AB, right? Okay. In the to prove section. Yes, Harsharida.
Yes.
Okay. See here, you want AB on the left hand side. And in the figure, AB is actually AP plus PB, right? AP plus PB. So I am keeping them on the left hand side, as you can see. Understand? See,
Yes.
I could have written BQ on the left hand side and PB on the right hand side also. Ultimately, they are equal. But I am writing this way because when I will add them, so I'll get AB, which has to occur on the left hand side. And similarly, I want CD on the left hand side. So CD is DR, sorry, CD, yeah, DR plus CR. So that is why I'm keeping them on the left hand side. I hope it's clear now. Okay, so now you add them. So DR plus CR plus BP plus AP is equal to DS plus CQ plus BQ plus AS. Now DR plus CR. See in the figure, DR plus CR becomes your CD. PP plus AP becomes AB. Now DS plus what? Okay, CQ is here. So DS plus AS. Yeah, so I have this here. This is my DS and this is my AS. So I can combine them together. So if you want, you can combine in the first step and then you can write. Then CQ plus BQ you can combine. So CD plus AB. Now DS plus AS becomes your AD and CQ plus BQ becomes your BC. So this is proof. Okay, I hope you have written. So one more question at least we can do.
Yes, ma'am. Done.
Okay, so in this figure, xy and x dash y dash are two parallel tangents. So they are already parallel to a circle with center O, and another tangent AB. Okay, AB you can see in the figure, right? With point of contact C intersecting xy in this at B. Okay, prove that angle AOB. Where is AOB? So this angle you have to show 90 degree, right? Okay, so let us write down whatever given to us first of all. XY is parallel to x dash y dash. This is given. And XY is tangent at point P. X dash y dash is tangent at point Q. And AB is a tangent at point C. To prove angle AOB is equal to 90 degree. Mm, Okay, so let us do one construction here. I join this, okay, OC. So construction is join OC. Okay. Mm, Okay, so we can do it this way that mm, okay, so first of all, I'll try to show that this angle and this angle they are equal, right? This I can do if I show that these two triangles are congruent. Which triangle? This one and this one. Is that clear?
Yes, ma'am.
Okay. Now, if I consider these two triangles, so first thing I can see that OP is equal to OC. They are radius, right? OA is equal to OA, which is a common line. And the third thing is angle OPY will be 90 degree and similarly OCA will be 90 degree. Yes?
Yes, ma'am.
Okay. So that I can do. Or in place of angle, I can also take, okay, OP is equal to OC. I can also take AP is equal to AC, isn't it? In place of angle. Because the tangents drawn from an external point are equal in length. Yes. So mark it angle 1 and mark this angle 2 in the figure. So in triangle, OPA and triangle OCA, right? So there are three things here. First of all, OP is equal to OC. Why? Because they are radii of same circle. So obviously equal radii of same circle. And then you have OA is equal to OA common. Now in place of angle, I can say AP is equal to AC. Can I say that, Rida?
So we need to prove all the angles are equal.
No, no. Just wait. Tangents are drawn from point A. So ultimately they are equal. No, not all the angles equal. Angle 1 and angle 2 equal. And similarly, I'll choose the next pair of triangle. So I'll show this that angle 3 is equal to angle 4. And then I'm going to add all of them and we will get the result.
Okay.
Yeah. Okay, so this much is fine. So by
Yes.
CPCT, angle 1 will be equal to angle 2. So by SSS, a triangle OPA is congruent to triangle OCA, and by CPCT, angle 1 is equal to angle 2. Okay. So just 1 minute, I'm inserting the figure again.
Can you scroll up it?
Hmm. Right?
Yes, ma'am.
Okay. Now, same thing I'll do here. So I have joined it. So this was 1 and this was 2. Now take this triangle 3 and 4. So similarly, I think you don't have to prove, you can write similarly. Triangle OCB will be congruent to triangle OQB. By the same method, they will be similar. Sorry, congruent. Okay. So you can write similarly. And by CPCT, this time angle 3 will be equal to angle 4. Is that okay?
Yes.
Yeah. Mm, now because PQ is a line, okay? PQ is a diameter or it's a line. Is it given in the question that it's a diameter with point of
But it's
contact?
shown as it's passing from the center.
Yeah. So anyway, PQ is a line, right? PQ is a line. Now all the points are, sorry, all the angles are lying on it. So that means angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 180 degree. Is that clear? Because linear pair. Okay, now angle 1 and angle 2 are equal from 1. So I can say I can replace angle 1 here because ultimately I want the answer in terms of angle 2, right?
Yes.
So angle 2 plus angle 2 plus. And similarly, I want the answer in terms of angle 3. So I'll keep 3 and I'll replace angle 4. Is that okay? So from 1 and 2 I have used. So from 1 and 2. So that means twice of angle 2 plus twice of angle 3 is 180 degree. Okay. So I can take 2 common. Angle 2 plus angle 3 is 180 degree. And angle 2 plus angle 3 is 90 degree. Now what is angle 2 plus angle 3? This is angle AOB, which is 90 degree.
Mom, can you scroll a bit up to the congruency?
Hmm. So the second pair you can just write similarly. Okay, don't prove it. Because same steps you will be using.